Hi, here the question given is a triangle is given to you, three vertices are given. They're asking for the measure of angle B. Okay. So if you see the measure of angle B, angle B is formed between the two sides AB bar and CB bar. In the vector format, we need to take. Okay. The AB bar is nothing but to B minus A, we need to find out. In fact, we can write it as OB bar minus OA bar, the head minus tail. For the AB bar vector, from the center, the position vector is considered. From the center, the position vector. In x direction, 1 unit. In y direction, minus 5 units. So this minus this is a vector AB bar. We can name it as some U bar like this. OB minus OA, just subtract y x and coordinates and y coordinates. So 1 minus 4 is 5, 5 I cap minus y coordinates again, minus 5, minus 2, minus 7 j cap. So we can write in a component format like minus 5 comma minus 7. This is U bar vector. Now angle B is formed between AB and CB. So CB bar vector also we need to find out. So CB bar vector is equal to OB minus OC. That means B minus C in fact. So whenever they give you the points, if you want to find a vector, see, just you subtract the corresponding x and y coordinates. So OB minus OC is how much? Minus 5i. So because 1 minus 5, I have 1 minus 6 I have done. Now minus 5 minus of minus 2, that is minus 3, minus 3j. Let us name this vector as V bar. Now the cos of angle B is equal to U bar dot V bar by mod U into mod V. This is the formula. So what is U bar dot V bar? Just corresponding elements you need to multiply. I mean to say the first vector is 5 comma minus 7. You have to multiply with minus 5 comma minus 3 whole divided by the modulus of U bar means x and y coordinates. You have to square it and add square root of 5 square plus minus 7 square into modulus of V bar is minus 5 whole square plus minus 3 whole square. And here in the dot product, you just do the cross multiplication of the like term. I mean, x coordinate and x coordinates you will be multiplying, and thereby y and y coordinates. Corresponding elements you need to multiply. So answer is coming as minus 25 plus 21 whole divided by 49 plus 35. How much it is U1s? Square root of 49 plus 25. So root 74 times root over 34. So when we use the calculator now, cos of B, so we write angle B is equal to cos inverse of this whole part, which becomes to be 94.5 574, rounded off to 3 decimal places. Okay. So the main point in this question is you need to identify whenever 2 points are given to you, A, B. A point is -4, comma 2 and B point is 1, comma -5. And you want the vector AB bar. The AB bar, if you see, so head minus tail, otherwise you can say just subtract the coordinates of the B minus A. And in the writing the position vector format, position vector means every point is having a vector with respect to the origin. I mean to say, if you see the B point is there. So how the B point has come? The X coordinate is 1 unit, Y coordinate movement is -5j. So 1i minus 5j. That is called position vector. But this time, this origin and all, no need to show in the question. Directly we can write, just say OB bar minus OA bar. OB bar means the point B itself. Position vector means the point. Okay. So 1 minus of -4 is 1 minus of -4 in the resultant movement in the X direction. And my movement is also -5 minus 2 into j cap, which comes to be 5i minus 7j cap. That is how we found the vector AB bar. So here AB bar vector, CB bar vector is found, and angle between the two vectors formula is this much. U bar dot V bar by mod U into mod V. I hope you have understood. Direction with a force of 67 newtons, and another rope pulls barge directly in the north direction with a force of 54 newtons. So find the magnitude of the resultant force acting on the barge. So very interesting now. So this type of questions you should understand the east direction. So directions, let me consider like this. This is north and south. This is standard way of representing the directions. Hope you'll be knowing this. This is west, right? So one vector is working in the east direction, that is 67 newtons. I'm keeping newtons as n. And one more vector is working in north direction is completed. North direction is completed. Oh, sorry, east direction. This is right. 67 newtons in the east direction. And one more is north direction, 54 newtons. The north direction is like this. North direction. So how many units of force? 54 newtons. So this is V bar vector and this is U bar vector. So when to see, vector is used for mentioning the direction. And the 67 newtons comes out to be the modulus of U bar. The modulus of U bar is 67 units. So vector will be having a magnitude at the same time direction. So one vector U bar is working in the east direction, rightwards. And the measure of that, I mean the length of the vector is 67 newtons. And now the V bar vector is working in the north direction and its measure is 54 newtons. So when you want a resultant, to always follow the technique of taking the coordinates first, and origin is my starting point. Origin is my starting point. So what you have to do is, you have to just draw the two vectors in east and north directions. Let me elaborate. Here is the first vector of 64 newtons in the east direction. Hope you have understood this. Right? And after completion of the movement in the east direction, we have a direction in the north. This is a bit smaller vector because the modulus, the length of the vector is 54 newtons. So what happens here? 64 newtons, 67 newtons, sorry. 67 newtons in the east direction. And after completion of this movement in the east direction, from there, we have done again and a vector of V bar, which is equal to 54 newtons. Okay. So this is your final position. So now the resultant vector, magnitude of the resultant vector they're expecting from us. The magnitude of the resultant vector is nothing but, if you see in the first quadrant, it is 67 comma 54. We can write this vector. Now, this is called resultant. I mean, we can say it's a displacement vector also. From the center, from the origin, the starting point, you made a movement of 67 newtons in the x direction and 54 newtons in the y direction. The measure is this one. Y direction in the sense, I mean to say the north. Okay. So whenever you say the resultant, you just add these two vectors, u bar plus v bar. Okay. So the resultant is nothing but, in x direction, 67 newtons of this I plus 54 into j. And if you want the measurement, I mean the modulus, the magnitude of the resultant. Magnitude of the resultant is nothing but, using the Pythagoras theorem, the root over 67 square plus 54 square. Now you calculate this using the calculator. So when we use the calculator, we are getting it at 86.05. 86.05 newtons. Okay. And here they have not asked the direction of the resultant vector, but I'm interested in finding out that also. So please find out what is the direction of the resultant. I mean, we should say the resultant vector angle is how much? How much angle is made with the x direction? That's what we need to find out. If you consider the resultant vector point as x comma y, the theta, if you want, the direction, they have not asked in the question, but we are finding out for out of our interest. If the direction of the resultant vector is equal to tan theta is equal to y divided by x. You just divide the y and x coordinates. And the angle is obviously in the first quadrant, right? So 54 divided by 67. And theta is equal to tan inverse of y by x. This is the generalizer formula for measuring the direction. Every vector, whatever vector you consider, from the x-axis, you have to calculate in the anti-clockwise direction. I mean, counterclockwise direction. So tan inverse of 54 by 67. So this you have to calculate, use the calculator now. So it comes out to be 38.87, 38.87 degrees. Right, friend? So the resultant vector, we have two different methods to mention the direction of the resultant vector. So one method I'm finding here. So please closely observe this one. The direction is very, very interesting. The direction. The magnitude is already done as he asked for 86 newtons, 86.05 newtons. The direction is from the east, he is going towards the north, isn't it? From the east, he is moving towards the north. So we write here east 38.87 degrees north. This is the way we write the direction. Okay. 38.87. But how is the direction? From the east towards north. See here, east is the initial arm of the angle and north is going to be the final angle. So east, north. From the east, 38 degrees, 87 degrees towards the north. This is one style of writing the direction. Otherwise, we can write the same thing in the name of the bearing also. Bearing. So what is that bearing? Let me explain you this. The bearing is calculated always in the clockwise direction from the north. So presently the resultant vector is making an angle. This is the resultant vector. This is resultant. The resultant vector is making an angle of 38.87 degrees from the x direction, east to north. So what is the bearing is from the north always measured in the clockwise direction. Bearing is calculated, bearing calculated from the north in the clockwise direction. Clockwise direction. So that means, so from the north, we have to go for calculation of this theta, the bearing, in the clockwise direction. So please do it from 90 minus, I think, 90 degrees minus 38.87 degrees, isn't it? So 90 minus 38.87 is comes out to be 51.13 degrees. So it is having a bearing of the resultant vector is having a bearing of 51.13 degrees. So no need to mention here directions here because the bearing is calculated always in the clockwise direction from the north. Hope this concept is clear to you.